All right, so this video we're going to be talking about absolute value functions and inequalities. Now, let's go back and let's just think really simply, what does absolute value mean? If I said the absolute value of 5, that equals 5, what do these actual bars mean? What they mean is distance from 0. Let's think about them like that. So if I said the absolute value of, let me erase that and just put a question mark. The absolute value of something is 5. What could I say that number is? Well, if I look at my number line, how many numbers are 5 away from 0? Well, let's see. 1, 2, 3, 4, 5. The number 5 is, so that works. And 1, 2, 3, 4, 5. Negative 5. So there are actually 2 solutions to this, because there are 2 numbers that are 5 away from 0. So the solution to this, or so when you have an equation like this, you could potentially get 2 answers. So let me show you another example. The absolute value of what is 7? Well, that could be 7, or it could be negative 7. But let me show you what happens as it gets a little more complicated. The absolute value of x plus 1 is 10. So let's pretend we don't see this right here. Okay, let's pretend we don't. What numbers are 10 away from 0? Well, we know that 10 is 10 away from 0, and negative 10 is 10 away from 0. So, but then we can't just say that that's what x is. We actually know that it's what this is. So here's what we do. I say that x plus 1 could equal 10, or x plus 1 could equal negative 10. And then I solve those problems. So x equals 9, and x equals negative 11. So look what happens. If I plug in 9 here, I get 9 plus 1, the absolute value is 10. Great. What about if I plug in negative 11? Negative 11 plus 1 is negative 10, and the absolute value of negative 10 is 10. So that's correct. So you could get 2 different answers here. So in general, as you're thinking about absolute value equations, you could potentially get 2 different answers. So let me try another one. What happens if I have a number outside of the absolute value sign? Well, in order to split into our 2 cases, you can see that we split into 2 cases right here. Before we can do that, we have to get the absolute value bars by themselves on one side of the equation. So the first thing I'm going to do is just divide both sides by 2. And now I can split into my 2 cases, right? And all you have to do for the 2 cases is put x minus 3, and think, what numbers are 5 away from 0? Well, 5 and negative 5. And you solve. So x can equal 8, and x can equal negative 2. And you can always check your answers, and you always should. Because what happens is sometimes you get an answer that doesn't work, and those are called extraneous solutions, a solution that does not work when checked. Let me show you an example of something like that. So what if I said this? The absolute value of x plus 1 equals negative 5. Okay, look at this. So I would say x plus 1 equals 5, x plus 1 equals negative 5, right? I get x equals 4 and x equals negative 6. Well, when I plug in 4 here, the absolute value of 4 plus 1 should be positive 5. Uh-oh, that doesn't work. What about negative 6? Negative 6 plus 1 is negative 5. Well, the absolute value of negative 5 is positive 5, so that doesn't work either. So you have to be really careful. If it equals a negative number, if you get an absolute value equals a negative number, it's going to be no solution. So that's just a little introduction. You'll see kind of some steps right here to solving an absolute value equation. Isolate the symbols if necessary, so get the absolute value symbols by themselves. Does it equal a negative number, right? If it equals a negative number, we're going to have no solutions. Split into your 2 cases, right? And then check your answer always, always, always. So this was hopefully just a good little introduction and reminder of what absolute value